Special products of binomials. So our objective for this lesson is to find special products of binomials. What we mean by that is there are certain patterns that if we recognize the pattern, then we can shortcut the multiplication process. And these patterns happen often enough that knowing that shortcut can save a little bit of time. Now, the shortcut isn't necessary. You can do them without the shortcut, but it can save some time if you recognize it. So the first thing we're going to look at is the sum and difference pattern. So it's important to note here that here I am multiplying, so this is a multiplication. And in this multiplication, the first term in each of these binomials is the same thing. They're both A's. The second term of the binomial is B, but this one is the opposite. So it's important to note, oh, I didn't mean that one. One of them is add, and the other one is a subtract, or a plus a negative. Again, we could write that as a plus a negative B. So for this pattern to work, the first term in the binomials have to be the same thing, and the second terms have to be opposites. Okay, so we're going to go ahead and we're going to multiply this out using the distributive property. So I'm going to multiply out A plus B times A plus a negative B. And you'll notice that something happens, and it will always happen, because this is what we call a general case. Because in this case, A and B could be anything. A could be X, it could be 2X, it could be XY, A could be anything. So this is what we call a general case since it's not specific. What we mean by that is it's only variables. These are all variables. So those variables could represent anything. Okay. So if it works for a general case, it'll work for all of the cases. Okay. So here, let's go ahead and let's start. We're going to distribute through the A. So I would take A times A, which is A to the second, and then A times negative B, which is a negative AB. And I'm writing them alphabetical, A times B, negative A times B. And now we're going to multiply by B. So I'd have B times A, which is a positive AB, and then a B times a negative B, which is a negative B to the second. Okay. So, and now what we notice is look at these middle terms. I have a negative AB and a positive AB. They're opposites. So when I add them, I can add them. They're like terms. They're both ABs. When I add them, I get 0. So really here, all I'm left with is A to the second minus B to the second. And this pattern we call a difference, because a difference is just a subtraction of squares. Because if you notice, both of these are squared. It's A squared and B squared, and it's a subtraction. So it's a difference of 2 squares. So we call it a difference of squares, or sometimes the difference of 2 squares. Okay. So here we have a difference of squares. So this is our pattern. Whenever I am multiplying two things, two binomials, two terms, this only works for binomials. Again, it's a very specific shortcut for a very specific pattern. If I'm multiplying two binomials and the first terms are the same and the second terms are opposites, I can just square the first term, square the second term, and subtract them. Okay. But first, it's noticing that it is that pattern. So here I'm multiplying. So the first thing I notice, first term here is the same, X and X. And then I'm going to go ahead, I'm going to rewrite this subtract as plus a negative 4. And then the second term's positive 4, negative 4. So this fits what we call our sum and difference pattern, because sum and difference, because it's a subtraction. So by using my shortcut, I take this first term, this X, and I take it to the second power. And then I take the same term, next term, which is a 4, and I take that to the second power, and then we subtract them. So, and then now we just have to simplify that out. So I would have x to the second minus 16. Now, you don't have to use a shortcut. If you're not sure if you're right, for example, let's say it's a test and I want to make sure I'm right. I want a really good grade on this. I would just distribute. You can distribute this guy out, and you will just get this middle step, and those middle terms will cancel out. We can go ahead and we'll do this one. So I have x times x, which is x to the second. And then here I have x times negative 4, which is a negative 4x. And now we're going to multiply by 4. 4 times x is a positive 4x. 4 times negative 4 is a negative 16. And again, those add to 0, and I'm left with x to the second minus 16. Same answer. I just did it a slightly different way. Didn't use the shortcut and multiplied it out. Next one. Hey, this one looks slightly different, but if you notice this first term, negative 4x is the same. Second term, 3 and 3. And then we do have a subtract and an add. Multiplication is what we call commutative, which means that it doesn't matter the order. So meaning I could flip these around if you want the add to come first. When I'm multiplying, I can flip-flop the order when multiplying. If you want the add first, it doesn't really matter which comes first, the add or subtract. Okay, so if we use the shortcut on this, I take this first term, which is negative 4x. Okay, and this is where you have to be very, very careful. I need to take that whole first term and take it to the second power. Okay, and then so there's my negative 4x. And then I do the same thing with the 3. Take the 3 to the second power, and then we subtract. So I have to take negative 4x, and if you're not sure, multiply it out. Negative 4x times negative 4x. Negative 4 times negative 4 is 16. X times x is x to the second. And then the 3 to the second is 9. So I have 16x to the second minus 9. Again, you can distribute this guy out, and you will get to the same end result. Hence why it's a shortcut. Okay. All right, next one. So here we have, look to see, does the shortcut work? The first term here is x to the second, x to the second. First terms are the same. Second term, 5 and 5. Yep, and then we have an add and a subtract. So yes, this will work. So I take this first term, x to the second, and I take that to the second power. Take the second term of the binomial, take that to the second power, and subtract. So x to the second, if I'm not sure, x to the second times x to the second. If I'm still not sure what to do, that's x times x. That's x times x. So really I have x to the fourth minus 5 to the second, which is 25.